Yeah.
Is there any way to like stop it?
Yeah. You can you can stop kernel. Let me show my screen. So basically, the way how you do it, press this button.
Yeah, but then,
And
but this will error, and then the best parameters, the next step wouldn't give you the best scores or anything.
yeah. Does anyone know if there's a way to kind of just organically stop it?
I mean, like even if you stop and start again or something like that.
Yeah, because I know FastAI has early stopping, and that's a class you could actually customize and stuff. I don't know about scikit-learn. Let me just show FastAI early stopping callback. It's a callback function. I was just going through FastAI session 2, and I found this. So stop training if a given metric validation loss doesn't improve. So you can actually like tune, like and save the model at every epoch, or the best model for a given metric validation loss. So so this is save model callback. So FastAI has classes like these that could help you to kind of just do early stopping and also save models at every epoch. With and you can just kind of safely terminate the process, if you will. Then, but I don't know much about scikit-learn what in terms of whether we can do early stopping or not. Let me just
Okay.
Google it as well, I guess.
Yeah, no worries.
Sure. Before running, let's make a, yeah, yeah. Okay, I can't find an immediate answer. So let's just keep going.
Sure.
Okay, does anyone have a question, other questions about this? We're just replacing grid search with randomized search. And usually randomized search is probably what you should use when it comes to the case that you don't even know where the range of your parameters should be. So instead of doing a grid or a set number of parameters or a list of parameters, you should really do a distribution of parameters, and kind of randomly sample from that distribution. And that's what he used. This is what he used. And I was just kind of testing it with a list and random integers. Now, I didn't understand what reciprocal was. I didn't understand what that was. So I kind of just basically just test it. And this is what happens to, the functions that you don't know. And a lot of times, like reading this might not help either. Like it still doesn't explain what reciprocal means from SciPy's documentation. But like if you just test it and doing 100 samples, okay, so we now know perhaps it's just range of numbers between 20 and 20,000, and it takes some sort of distribution, and you randomly sample 100 of them, if you just call this function out of reciprocal. And same thing with here. The scale is probably just, let me just see if we can get an explanation here. Hmm. Exponential continuous random variable. Cool. So that's that follows the exponential distribution, and the scale of 1.0.1. You can probably look it up. Let's see if it mentions to shift or scale the distribution. Use the lock or scale and scale parameters. So basically, you're trying to, if you want to scale the distribution, you can do that here, and basically, okay, so we're applying this to the randomly sampled 100 numbers out of that distribution. Okay. And with randomized search CV, you can specify the number of iterations here, and specify CV here, and when it, then if you have CV of 3 and number of iterations 10, then that's 30. And you can tell from here, it says fitting 3 votes for each of the 10 candidates, and that's totaling 30 fits. So that means we have 30 epochs basically. And it took 6 minutes for me to finish that. And
I just one quick
yep,
point on on this randomized search CV, and then about the 6 minutes. You see on the first line, it's using a one concurrent worker. That means it's using only just one core. So if you specify the parameter as n jobs -1,
yeah, has anyone tried that? I don't know if it works on my computer. Has anyone tried that? I mean, I probably have two processors, if I remember correctly. Has anyone tried it?
I haven't tried it on this one, but I've tried it in the past, and it does speed things up. But you should get a speed up if you get it -1.
So it's going to use all the cores, like the cores. So it's going to start using all the available cores on your PC. However, mind it, one thing I observe it, the memory doesn't get released. So for example, if you run the grid search with the n jobs is equal to -1, and it finishes, and right after it, if you start using this randomized search again or anything else, that may error because I think memory or CPUs are not released by the previous job. So that's what small observation. So kind of that sucks, but that's the only negative.
How do you release it? Do you know?
No, I haven't. I haven't looked. So just wait. I'm sure. And then again, that's a good question, and I think I have seen. Jeremy has some method where he cleans the memory, but here I'm not sure whether it's the issue is whether related to a memory or a CPU. But
yeah. I mean, correct me if I'm wrong. I believe FastAI uses CUDA. And there's way like you can detach from CUDA. And perhaps that's a way, I don't know, to release like your memory when you kind of just detach it.
Well, here we're not actually using GPU. We're using just the cores of your CPU.
CPU, right?
Yeah. When you use n jobs equals -1, that just says use all of your CPU cores, and most people's machines have like 4 cores these days. So at least, yeah, it should help.
Okay, I don't know why it's not even returning results. Maybe I typed in too many.
It's probably set -1, and the other thing is I don't know how many cores Colab provides you. Colab is different from what your machine is providing you, right? So if you run it locally, it's going to be different. If you run it on Colab, it's going to be different.
Yeah. Anyway, I'll try this later on and see how it goes. But cool, good to know. And this was the previous result I had. And you can see like with a kind of a randomized search, now RBF has a better result with like gamma at 1, C at 10,000. So like you know, because previously you probably didn't know where the what the range of RBF parameters should be searched, and now with this randomized CV, randomized search CV, we can start kind of getting some appropriate parameters for RBF as well. Cool.
Yeah, we should note that with a linear kernel, it doesn't, it's not using gamma.
Right. So yeah,
you mentioned something about you should use randomized search CV when you don't know where your parameters are, right? That is not completely true, though, right? Because you still need to start mentioning where you want to start from, where you want to stop. So
sorry, I couldn't hear you. Can you speak louder?
Sorry, can you hear me now?
Yeah.
Better? Okay. So you were talking about randomized search CV where you use it when you kind of have no idea where your hyperparameters lie.
Mm-hmm.
From my understanding, it basically is very similar to grid search CV. The only, you still have to mention what your kind of starting point is and what your ending point is, kind of the range in which you want to still search. And your n iters in randomized search CV is basically going to say if n iter was 10, it's going to randomly search for 10 points in there. Whereas in contrast, grid search CV, you would have to mention what your grid points are explicitly, and then it would do all the possible combinations.
Right, but the thing is, you might miss a lot, like when you just try to provide bunch of kind of points to search, grid search, but randomized search actually uses distribution, so that's the biggest difference here. You're actually sampling from a distribution, so you're much less likely to miss a range of values than grid search. That's my understanding.
That's exactly right. But as Rekel pointed out, the way these things are implemented is the way you call them is indifferent to the way they're implemented. So you call when you call randomized search, or whether you call grid search, you still have to specify a range and you have to specify the number of points. But so what Rekel said is correct. But then what you said is also true, that when you let it do a randomized search, it finds the regions in parameter space that are more likely to have the right values in them. So it's my feeling is that randomized search is always, most of the time, going to do better than grid search. But you can try both and see what happens.
I agree with that. I also think randomized search is better to go than grid search with. But the point that, like I was trying to make is that you need to still specify the input and output. So it cannot be, you don't know where your ballpark is.
You still have to guess where the best parameters lie.
Mm-hmm. And the second thing is, I don't think you require a parameter distribution. You can pass in a set of values. Like I think if it was like a random forest tree, if you were saying n estimate is 1 to 100, it will randomly search for, let's say, 10 different tree numbers in between there. So in that scenario, it's not going to be distribution. It's just going to pick out some numbers between those two things.
You said it doesn't have to be, you don't have to...
As far as I remember, you don't need to pass in a distribution. See, that's what it says, a dict or a list
of parameters to try. If a list is given, it's sampled uniformly. So yes, basically, even if you just type in a list, which I did up here, right there, it will just be sampled uniformly. But it would, so it would just be all these numbers, and it will just sample a bell curve, and that's it.
So that's what, it won't be a bell curve, right? If it's uniform, it's going to be like literally randomly between those values, right? It's going to pick any number between those two values.
Oh, that's right. Uniformed. Yes.
Right.
Yep. this is the range that he specified, right? So this
Right.
was what I tested, 20
Yes.
between two.
Yeah, I still didn't understand what exactly this reciprocal distribution is. I need to figure that out.
Yeah, me too. But this one is exponentiation.
Right.
Well,
Yeah.
reciprocal distribution is just distributed as 1 over x. So it goes to infinity, or it goes very high at 0, and then it starts to come down at large values of x. That's all it is.
If you look up at the SciPy documentation that Wenchang was just looking at, there was some log b by a. Is that just for like scaling numbers into reasonable ranges? This is the exponential one, the next link, I think.
Which page? On scipystats.x, scipystats.reciprocal, is that what you're?
Yeah. Have you opened that one? Yeah, right there. So if you look at that, it says reciprocal speed is x, comma a, comma b. So x is your input.
Mhm.
So you're sampling 1 divided by x times log of b by a. I still can't understand it.
Yeah, that's just a constant. That's just a scale factor, right? But the mainly is it goes as 1 over x.
Oh,
See,
so you're saying it
log
goes
b
1
over.
over x, and you're trying to somehow limit it between a and b.
Well, you have to normalize it. If you specify that it has to be between a and b, then a probability distribution has to integrate to 1. It has to sum to 1, right? So that's just the normalization factor.
Right. Okay. That makes sense now. Okay. Yep.
Cool. Okay. So, anyone else has any questions on this problem?
So did you try grid search CB versus randomized search CB and see which one was better?
Well,
Or did I miss that?
Yeah, no, this helps us to find some good parameters.
Oh, right. Then we have to evaluate. Then we have to evaluate after that.
Yeah, and this did not, right? So this kind of just this one was kind of, but all the other ones were not, like, because this is too small, and we should have tried a larger one with RBF. Cool. So I want to. My plan is to go through 3 problems, and we'll review the 4 and 5, because the 4 and 5 is pretty straightforward, and the biggest one, the third one, and that's also the hardest one. I wouldn't expect everyone to finish problem 3, but unless, of course, you're really familiar with customizing your own transformers with random forest. But like, take a stab at it. And let's see how much you can finish, and we'll time it with 20 minutes, then we'll talk. Okay. So just to give everyone kind of a head start, if you don't have any idea where to start, take a look at page 68, the combined attributes adder. That's where he kind of showed how you can kind of customize your own transformer. And you kind of have to kind of follow a certain pattern, like inherit like these two classes, base estimator and transformer mixing.
Amy, can I close the door?
Hey, are you on the call?
Yeah.
My technical advisor.
Okay. 20 minutes is up. This one is a little challenging. Cool. So, I mean, he did it in a way. I was trying to do it in another way, but he used this numpy.arg partition, which I kind of had to look up as well. Let me just shift tab this. Perform an indirect partition along the given axis using the algorithm specified by the kind keywords. Returns an array of indices of the same shape as that index data along the given axis. Anyone has some good thoughts on using this function to kind of extract the top features?
I think it's kind of like an argmax, but like np.argmax would give you just the max value. Here it's more like top k values is what you're kind of trying to do. Or rather, if you look at only np.arg partition, I think the function that it's supposed to do is return the indices of how your data is ordered. So if you're given like certain, so actually, yeah, since you're doing that experiment down there, if you do 245 is equal to 1, 2, 3, 4, 5, 6, 7, you've written that, right?
Yeah, I was trying to do that.
Right, can you drop the NP sort? Because I have certain questions. I don't know what that minus in that -3 is.
Yeah.
I feel like it works with 3 too. So
Yeah.
I'm also not very sure.
Yeah, it works with 3 too.
No, I don't think you need to change the last 3 too. That one,
okay.
No, that, yeah, that's how I think.
That's something that bothers me. Like, what is this arg partition?
So can you just print out what np.arg partition, just that function returns for your A?
Oh, just okay.
Along with np.array A1 and 3, yeah. If you just pass those things, yeah.
And I believe I have to embed array. So it does something like this, and it adds a 0 for some reasons.
So, that is weird. Okay.
Anyway, I was trying to go from like, because he was basically just using, you know, zipping the future importances and attributes that we got from the random forest, right? And reverse it and just do that. And basically this should match whatever it is that you have. Forget about this. This should match like basically this. So 0 is this. So that's 0 point, that's this. 1 is this. So that's this, right? And 7, 1, 2, 3, 4, 5, 6, 7, 3.66. So that's this. And 9 is this, right? So, sorry, this, and that's this. So basically, in the end, you're just trying to look. We got these top features, and we just need indexes from this feature importances, right? So I was trying to do this from a NumPy where standpoint, but I got an error which I haven't been able to kind of solve. But maybe it's because the digits becomes smaller, and perhaps that was an error. I don't know. I haven't looked up on this error yet. But
you can
this
probably use something like np.close and then kind of give you a tolerance. np.close. So that basically checks for whether values are close enough. And I think, yeah, that's, I mean, something to that effect. You can check what it is. I think it's close all. That's it.
Doesn't say it has an attribute. Anyway, I'll look it up. But basically, that's what it is. And just kind of illustrate what he is trying to do is he's just trying to extract indices of the top K features, as it's explained from the function's name, and kind of pass it into this inherited instance method. And also when you transform, you kind of use that as your features. And I don't know what happens underneath, but he kind of just, so this is pipelines into here. And if you remember what we had from full pipeline, let me just get the full pipeline and let's see what it looks like. If you don't remember. Right here. So we have num pipeline and one hot encoder here. So basically just, you know, a bunch of data transformations, pre-processing, and then we kind of just use the top feature selector. One second. Top feature selector and following that. So right here, and then we fit transform. So basically, this has to be called fit, and it has to. I think it has to return self. And let me see. Yeah, so this is kind of the pattern you kind of need to follow. It needs to return self. Then it will call fit transform. I still have to kind of dig deeper into like how the customized pipeline works. Anyone has any ideas, thoughts? No. Joseph? No.
I'm looking at this function arg partition, trying to figure out what it does.
Yeah.
I thought I understood, but then when I looked at the second example, it doesn't. So I'm still thinking about it.
Got it. Okay. Yeah. No, he has some. He uses some of those great functions that we don't have any ideas about, which is good.
That zero that we were seeing, Chang, is basically because it's returning indices. So you have written 1, 2, 3, 4, 5, 6, 7. So the indices vary from 0 to 6. So that's why you're seeing a 0. And what it's doing is, if you look towards the end, it has sorted that part in place. So that's why you have, I don't know where your example is currently. No,
it's
the one you have written.
It's actually not sorting in place. It's what it says it's doing is it says that if you identify an element in the array, then it will sort. It will place that element in its proper position in the array, and it will partition the array into all the elements that are greater than this one, and all the elements that are, so all the elements that are greater than the target element will appear to the right of it, and all the elements that are less than the target element will appear to the left of it. And both of those two partitioned groups are unsorted.
No, they are sorted, right? Because that's what you're getting back. So yeah, they're right there. So if you look at
it's sorted here.
Oh yeah, I'm just looking at the raw function arg partition.
Got it. Okay.
The function arg partition doesn't sort. It just identifies the position in the array, in a properly sorted array. What position would it be in? But then it leaves the left and right partitions unsorted. If that makes sense.
Yeah, that's
anyway,
right. Sorry, go ahead.
No, I mean, if you go to the function arg partition, that's what it does. It doesn't actually sort itself. But anyway, so you see he's applying sort to the result of arg partition.
Which again, I don't see why that is required, because towards the end he's doing the minus k, right? So that returns your k values.
Huh.
So like you say, NP arg partition, yeah, it doesn't sort in place because it's returning you the indices. But those indices towards the end, so if you look at Wen Chang's example, he has written 1, 2, 3, 4, 5, 6, 7.
Mm-hmm.
And when he did np.sort, if you run that cell, you ended up with 4, 5, 6, which basically returned the top 3 indices, which corresponds to 5, 6, 7. So why do we need to sort? I mean, in this example, I think Wen Chang has written everything in increasing order. Probably if you change the order up, maybe that will make some difference. I'm not sure.
And why has he written in his function? He has minus. He would have written minus
exactly.
3. So
I
what's
don't see
the
why
difference?
the minus 3. Yeah.
Yeah.
I was getting the same results.
That's because that's because minus 3 is the element that you said you wanted to have sorted. That position, element 3, is the one that has to be in sorted position. And so if you go minus 3
so
from the
5.
Minus 3 should be 5, right?
Right.
Yeah. Let's see, 5.
Or are we talking a minus 5 index, which is 4?
Okay, so the input to arg partition is the array and an integer and a minus k. So what's k? So k is like you want the top, you want the top 5, the top 3
exactly.
values, whatever, right? So
okay, yeah.
So you have to call arg partition with minus k. I don't understand that part. Oh well, let's just move on because we can do this on Slack later on.
Right.
Yeah, it's one of those things where I think he's doing it for this particular example, but if we were practically using it for our own business case, it would look pretty different with our own code, with our own use case, if that makes sense.
Yeah. It's probably better to write your own code and make it work than see how his cleverly constructed code does it. I mean, there's more than one way to skin a cat. So
yeah. Yeah, and I was trying to the numpy.where it probably would work, you know, if I tweak it a little bit. Just to, I mean, in the end, you just want the indexes, and that's all it is.
Yeah, yeah.
And I wonder what this does, like when it connects to a customized transformer. Does anyone know what is this calling? Because we have a fit and transform defined here, but what is fit transform when we call it?
That's a defined function in the package.
Right, and but what does it do when we combine these two together? What does it actually do?
It implements your top feature selector and actually does it. You know what I mean? So the transform means that it implements it. The fit. I guess. Let's see. What does the fit and what does the transform do? Both of them together just apply this to the data.
But this just returns the class
transform
itself.
basically just calls transform when checking in this scenario.
Well, look at what it's doing. Y equals set to none in fit. Fit says self X, so you take something, pass it through, it'll drop the Y. Transform sends back only the X.
Mm-hmm.
So that's, I think Wenchang's question is, you have a fit function, you have a fit method, you have a transform method, but you're calling a fit transform method. And what does fit transform method call here? Does it call fit? Does it call transform? Does it call both?
I think it has to call both because fit returns. It looks like fit returns the
class itself.
Fit returns the indexes. The let's see.
No, it just returns self.
It has the indexes, yeah.
Yeah, but self includes the indexes of the top K. So you need those indices to get, let's see, indices of top K. Let's see.
I mean, it looks like it's calling the transform because look at what you can do with this, right? Because after you fit transform this, you can just call 0 to 3 and returns the features. So it seems like it's just calling the transform function, and because that's what it's doing, right? This is the feature indices, and you're just returning a bunch of the
yeah,
feature
but you don't get the feature indices unless you do the fit. So you have to call fit first.
Sure. Yeah. So probably
it calls both. That's what it does.
So fit transform is just calling both, right?
Yep. Yeah, that's what it does.
One after it calls fit first, and then it calls transform after that.
Right.
Yeah. Yeah.
The only thing is that when you end up using it on your test set, you again do want to fit on that. So fit transform just uses the previous fit that it has calculated and just applies transform there.
Yeah.
That's what it's doing.
And this gets stored somewhere, right? Like in the inherited class. This one. This is probably the inherited method, right?
That is something you are setting, right? You're appending self with a new attribute feature indices, which is getting stored to that. Yeah.
Yeah. Yeah.
That's what I thought. Okay.
Yeah. Okay. Cool.
So you must be you have to instantiate that class feature, whatever that thing is called, top feature selector.
Yeah, you do. You do.
Right. So that object basically will have feature indices.
Yeah. Then you instantiate here, and then you fit transform. Yeah.
And then it returns your new data set with the right columns, only the important features.
Yeah. So let's just see. No, I didn't run this. Okay. So shape. Okay. 16502 and 5. It's because the K is 5. So that's what it is. You're returning 5 features. Why is this 0 and 1?
Those aren't labels, aren't they?
Those probably one of the categorical.
Could be.
Probably, yeah.
Yeah.
I think you can look at the feature names, right? If you put that, I think you printed that out somewhere. You can see what the feature names are.
Yeah.
I think it was printed.
Yeah, that's.
So if you look
That's
at
right.
that.
Right here. Probably no.
No, I don't think so. I think inland, right? Inland was whether it is inland or not inland, I think.
Inland or not inland. I wonder, okay, why is this order kind of different from the other one? The order seem to be odd.
What order are you talking?
Like, why is this number, why is this the 5th?
Isn't that arranged in the most important order?
Yeah, but this is the second. You're saying this is this.
Oh, yeah, that should be second there. Yeah, not sure what happened down there. Wait, why?
Anyway, I don't want to take too much time. Let's keep moving. I think we can figure this out when we've spent a little more time on this, and we can probably talk, either next Sunday when we do, more homework. I just want to kind of perhaps go through number 4 and number 5 because we're just like basically reviewing it. And without actually doing it, but because it's pretty straightforward. So number 4 is try creating a single pipeline that does the full data preparation plus the final prediction. So all it does on top of number 3 is just add this into the pipeline. And in this case, it's SVR, and it's using random forest, best params, and unpacking it. Let me just see what this looks like. Okay, so basically when we did our grid search, save CV, and we selected the best param, and that was the best param, and we kind of just put it in. Maybe this is just randomized search CV instead of random forest CV. Well, actually, this is random forest because and estimators are max features. So I don't know why he's using SVR. So it seems a little bit odd here to use support vector.
I guess he's using whatever model he found the best parameters for with the grid search, and I think that was number 1, right? So I think he said use the SVR for number 1.
Right, but how do you use random forest parameters in SVR?
You have to input them. That looks like SVR has to know something more than just the parameters. It has to actually have the fit. It has to. Oh, I see it. Let's see. Somehow inside of this, it has to be fitted and transformed. The data has to be fitted and transformed, and I wonder if it's smart enough to do that if you just hand it the model.
Oh, it is randomized. It's randomized search. It's not.
Okay, yeah.
Yeah.
So that's number 2. That's problem 2, right?
But it's still using random forest regressor though.
Oh, okay. Well, it doesn't matter which model you use. I mean, maybe he made a mistake. Whatever model you want to use, you can use. I mean.
Yeah, but how does SVR use like number of trees? That's what I'm.
It doesn't. It doesn't use the same parameters. So it would have to have its own parameters. SVR doesn't use trees. So.
Oh, I'm sorry. This actually gets okay. So he used the variables duplicated variables. So this is actually SVR, and he used randomized search CV here, and then he just directly used this, called this variable instead of the variable on the top with random forest. So this is, it's correct. Okay, got it. Sorry about that. Okay, so this was from the SVR anyway, cool. So basically, then it's just fitting it and checking the predictions. I still got to find out why this is what it is. Number of estimators, maximum futures.
So I think we did, we did two problems. One, we did select, I think we did a grid search for SVR, and then right after that, he wanted us to do a grid search for, or a randomized search for random forest, I think. And so the last version of parameters you ended up with was from random forest.
Okay, so it's probably
Yeah.
on my end. Got it.
Yeah, so all you have to do is rerun the model with SVR to get the best parameters for it.
Got it. Okay. Yeah, no, that's what happens when you use duplicated names.
Yeah,
It gets and also like it gets stored in Jupyter Notebook. Cool. Automatically explore some preparation options using grid search CV. And this was quite fascinating when I found this. I didn't know you could also do like imputation strategy. So kind of doing cross-validation with different strategies of imputation. That's quite handy. And again, you're just basically cross-validating on different imputation strategies. So that's fascinating. I did not know that. Cool.
So the imputation strategy becomes a hyperparameter to be searched over then, right?
Yeah, yeah. And so, and the best parameters have 15 features and also the most frequent. That's the imputation strategy that he used. Well, that's found out to be the best. So
What's
that
15?
It's number of features you select. It says apparently almost all features are useful. 15 out of 16.
Oh, 15 out of 16. I see. Okay.
Yeah, the last one, inland, seems to just add some noise. So this is quite handy because a lot of times we could spend a lot of time on imputation, and I think we can just literally, instead of using like median, most frequent, mean, why don't we just run this? So that's the 4 and 5 are pretty straightforward. So I thought we could just review them instead of just spending time. And plus, we kind of spent 2 hours previously already. So that's it. I want to thank you everyone to join this session. I know it's kind of, we don't have all the time to kind of finish everything, but again, the goal is just to get everyone started, get the snowball rolling, and just so that we can kind of now and go back and take a deeper look if you have time, and if not, at least you kind of have a good understanding, and at least you've tried some of the problems. So other than that, I will probably see you guys next Sunday, and we'll try to see if anyone has any questions on this, and also like kind of just start on chapter 3's homework.
Quick
Sounds
question.
great. Thank you very much, Wencheng. This is useful.
Just a quick question. Is there a reason why we are solving this in this 2-hour period rather than solving before and discussing? I just wanted to know.
Sorry, I couldn't hear you. Your voice is.
Can you hear me now? Sorry.
Yeah, a little clearer now.
I was just wondering, is there a reason why we're not solving assignments beforehand and then discussing and solving it on the fly right now like this?
Oh yeah, well the thing is, it's the same kind of philosophy, I guess. It's accountability philosophy, like that. We want to kind of just give you the most time. Like when you're done, you're done. Like you don't, and when you kind of join the session, then you're fully focused. But when you're out of the session, you can do whatever you need to do in your life. And because a lot of times when you do that, you take the element of procrastination out of the table. So that's what it is.
Okay.
Yeah.
Yeah, I think we'll keep more people in these sessions if we don't require that they finish the assignment first.
Yeah, absolutely.
Well, thanks again.
Yeah.